Okay. Uh, Whatever we have finished, let it be. We'll start that part again. So now, in the case of Diels-Alder reaction, I have discussed with you how it is important with respect to the organic synthetic point of view, because it is generating around four chiral center. Provided you are dine and dinophile, they are prochiral. So if they are prochiral, we will end up with the product which can generate up to four chiral center in this reaction. Why it is important in the organic synthetic point of view? Again, there are a lot of natural product synthesis which involves this Diels-Alder reaction as one of the step. Of course, they are multi-step synthesis process. One of the step in that is nothing but your Diels-Alder reaction, and that includes the preparation of the prostaglandins and some alkaloids. Then this Diels-Alder reaction is generally catalyzed by the Lewis acid catalyst. There are different type of Diels-Alder reaction. You may say there are some Bronsted acid, Bronsted base, even Lewis bases are there. So there are different ways of doing the Diels-Alder reaction, but the most preferred way is taking the Lewis acid catalyst. Now, why to take that catalyst for the reaction to get the better selectivity? I will discuss that part when I'm going to start with the catalyst part. Okay. Now, as I said, uh, we are not supposed to do only Diels-Alder. We are supposed to get some asymmetric part in that. So, if there are different chiral centers, now if I count over here, there are four chiral centers. So, if I count the stereoisomers 2 raised to 4, that means around 16 stereoisomers can be prepared with the help of this Diels-Alder reaction. But if I'm getting formation of the 16 stereoisomers, I won't be able to call this as asymmetric. So if I want this reaction to be asymmetric, I have to get predominantly one isomer. So how to reject the options of all those remaining 15 and to get only one isomer in the Diels-Alder reaction, that we are going to see the different ways, selectivity ways we are going to see, and then that will call it as asymmetric Diels-Alder. Now, in the case of asymmetric Diels-Alder reaction, the stereoselectivity can be observed in four different ways. The first one is Woodward-Hoffmann suprafacial stereoselectivity rule. Then we'll see the endo-exo rule. Then we'll see the regioselectivity. And then finally, we are going to go for the enantioselectivity or the distereoselectivity using that is actually called as the asymmetric Diels-Alder. But before I go ahead for the even the enantioselectivity selectivity and distereoselectivity, I said there are 16 stereoisomers possible. 16 में से बाकी सारी चीजों को rule out करना है. I have to go through this 1 2 3 point, and then only I'll understand why I'm getting the better selectivity in the case of fourth option. Okay. Now this one, that Woodward Hoffmann suprafacial stereo selectivity, that is nothing but the sin addition, or it's also known as the Alder sin rule. What it says that, as I said, there are 16 stereoisomers possible, or you can say 8 plus minus pair diastereomers can be obtained. But how these are expected to form? So for example, if I say, let us assume we have a dine and a dinophile. Okay. And if this reaction will occur, I'm going to end up with a cyclohexene. Now, this dine and this dinophile, they can approach each other in different ways. So there are different ways of approaching this. This you must have studied in the case of the pericyclic reaction. So dine and dinophile, both with a suprafacial manner. Dine is suprafacial, dinophile is intrafacial, or dine is intrafacial, dinophile is suprafacial, or both have the intrafacial selectivity. So when I say they are going to approach in suprafacial manner, they will give me around four compounds. Now four compounds in the sense two endo and two exo. So I'll get two endo compounds and two exo compounds. Of course, each endo and exo, again, they'll have the plus minus pair. Therefore, there are total four stereoisomers I'm going to end up. So this is like four pathway here, four pathway in this case, again 4 and 4. So there are total 16 stereoisomers. We are going to get it from here. But what the Woodward-Hoffmann suprafacial stereoselectivity says, these remaining three will be ruled out. And the only first option is the appropriate way of dyne and dinophile interaction. Now, why this is only the appropriate way? Then we have that answer with respect to the frontier orbital method. So before I go ahead, again, I'm repeating in this case, if suppose your dyne and dinophile, they are prochiral. You can see this example, this dyne and dinophile, these are prochiral. We will end up with the generation of four stereogenic center or the four chiral center. Now these four chiral center selectively, if I have to get, selectively if I have to get only one isomer, if I'll get in the reaction, that reaction I will call it as asymmetric reaction. Right now we can say there are 16 stereoisomers possible, right, with respect to these फोर कायरल सेंटर. अब वो फोर में से कितने फॉर्म हो रहे हैं? ओनली फोर. सॉरी, वो 16 में से कितने फॉर्म हो रहे हैं? फोर. Why 4? Because we are considering only suprafacial interaction. तो हमने 16 में से 12 को तो रूल आउट कर दिया. अब बचे हैं 4. अब वो 4 में हम आगे कैसे लेके जाएंगे? And selectively how we'll get the one that we are going to discuss. Okay. Now, in the case of the frontier orbital method, last time also I have discussed with you. This is psi1. This is psi2. Okay. Here, how many nodes are there in this limo of butadiene? There are two nodes. So this is which limo? And what about this? How many nodes? One node. So this is
Side 2.
psi 2. Okay. So when the dyne and the dinophile, they are going to interact, there are two ways possible. That is either HOMO of ethylene is interacting with the LUMO of butadiene, or we can say LUMO of ethylene is combining with the HOMO of butadiene. So any interaction can be possible, and this is thermodynamically allowed interactions. Okay, अगर तुम यहाँ पे देखोगे तो this is something, the orientation wise it is the appropriate one and thermodynamically allowed. So we can try with this orbital diagrams also. So we can say this is psi 1, this is psi 2, psi 3, and this is psi 4. So in all, what is happening when this butadiene is going to interact with ethene, we are going to form this, right? So this pi bond is the new bond formed, right? This pi bond is formed, and these sigma bonds, which are also, sorry, these sigma bonds, these are also formed at this stage, not this one. The sigma bonds, which are also formed. So we have to look after the formation of these bonds. तो ये जो ethylene है, they are actually interaction. This is pi 1 and pi 2. Okay. If you see this, एक सिग्मा बॉन्ड यहाँ पे है, सिग्मा 1, दिस इज सिग्मा 2, दिस इज पाई. ओके. अच्छा, ये कुछ उल्टा लिखा है, रुको, इसको ठीक करना पड़ेगा. दिस शुड बी फिल्ड. ओके, एंड दिस शुड बी एम्प्टी लाइक दिस. ये ऑर्बिटल ऐसा होना चाहिए, एंटी होना चाहिए इससे. सो दिस इज पाई स्टार, दिस इज सिग्मा 1 स्टार, एंड दिस इज सिग्मा 2 स्टार. ओके. तो ये तुम्हारा पाई बॉन्ड फॉर्म हो रहा है. दिस इज पाई बॉन्डिंग एंड दिस इज पाई एंटी बॉन्डिंग, राइट? दिस इज सिग्मा बॉन्ड फॉर्मेशन एंड दिस इज अनदर सिग्मा बॉन्ड फॉर्मेशन, राइट? सो दिस आर द इंटरेक्शंस अलाउड. अब तुम इसमें सिमेट्री असिमेट्री डिसाइड करते हो. तो ये कैसा है मॉलिक्यूल? सॉरी, दिस ऑर्बिटल, हाउ इट इज? psi 1 is symmetric. Pi 1
Symmetric.
symmetric. What about this?
Asymmetric.
Asymmetric. Then
Symmetric.
symmetric,
Asymmetric.
asymmetric,
Asymmetric.
asymmetric. What about this? Sigma 1,
Symmetric.
then
Asymmetric.
Sorry, asymmetric, and then
Symmetric.
symmetric,
Asymmetric.
asymmetric,
Symmetric. Asymmetric.
asymmetric. So now this is the, you can say, the barrier between the bonding and the anti-bonding orbitals, right? So is it crossing the boundary? And that's why these transitions are allowed transitions, right? So this is superficial interactions, which are the allowed transitions. So this is the explanation that you must have studied in the pericyclic reaction also. So in Woodward-Hoffmann principle, if I see according to that, we say out of those 16 stereoisomers, only 4 will be formed, because the allowed pathway is nothing but only superficial interaction. Okay. Now, when I talk about this superficial interaction, first of all, everyone knows that Diels-Alder follows the concerted mechanism. What is this concerted mechanism? What is the meaning of concerted mechanism? So this is like continuous breaking and formation bond, and that's why you end up with this product, right? So this particular reaction, we are saying there is only one way of forming it. That is nothing but superficial manner. Okay. Now in this pathway, since it is a syn addition is the most preferred product in this case. Now what is this Alder syn rule says? Now let us talk with respect to, let's say, with respect to, let's say, dinophile. Okay. With respect to dinophile. So I'm saying this is my one dinophile and this is my another dinophile. Okay. So these substituents which are attached with respect to this dinophile, look at them. If you look at this arrangement, they are cis to each other. And if you look at this arrangement, they are trans to each other. This is my another alkene. Okay. Sorry. Now I have to take the dine system. Okay. And therefore, now in this case, again, as I said, there are different approaches possible, but only one approach is possible, that is superficial manner. And when we have the superficial pathway, the when the reaction will take place, the products are formed syn with respect to the phases of dine and dinophile. So here what happens when you get this product? When you get this products, let's say this is my dine here, this dine is giving this double bond here. So my COOH group will be cis to each other. Either you can draw in this way, or there is another approach also possible, plus minus. So I can have this COH above the plane, but they will be syn with respect to each other. Okay. Second way, if I'll form the product here, I'll have this way. Either the COH up or another one will be down. So it is like whatever stereochemistry you have with respect to the dinophile, that will be retained in the product also. That is the, you can say, outcome of this superficial pathway. And hence we call it as Alder's syn rule. Syn rule in with respect to that, whatever the stereochemistry you have for those substituents in the reactant, that part will be retained in the product also. Okay. So here we can say whatever stereochemistry we have in the case of dinophile, that similar type of stereochemistry we are getting in the product as well. So if the two COH groups are cis to each other, they'll be cis to each other in the product also. And if they are trans to each other, that will be observed in the product as well. Okay. Similarly, when I talk with respect to dine, I've purposely taken this part because now we're going to talk about the different aspect, different examples of the deal setup. So there the prediction should not be difficult for you. That's why I'm purposely taking this, how the stereochemistry of the product will be dependent on the stereochemistry of the reactant. So you understand this part right now, then all the examples which we're going to cover after this will be easy for you. Okay. Now in case of dine, let's say dine is of two types again. इसको मैं R attach कर रही हूँ और इसको भी मैं R attach कर रही हूँ. Okay. So now look at this double bond. Okay. Look at this double bond. And these are the substituents on this double bond. How these substituents are with respect to each other? It is E. And what about the second one? ये वाला
E.
double bond? That is also E.
E.
Right? Right? Now, if I take this example, and let's see, ये ऐसे है. What about this? This is E, and this is Z
Z.
configure, right? So now we have different type of substituents. So stereochemistry is different. This is called as out system, and this is called as in out system. Okay, मतलब एक E है तो दूसरा भी E है. So both are outwards. So that's called as out system. And this is one in and one out. So it is in out system. So when this is my dine now, and then we have dinophile. So this is dinophile. It is present here. So when the reaction will take place, now it is completely depends on how the dinophile is going to approach. Now suppose dinophile is attacking from the backside. So when the dinophile will attack from the backside, these two R which are attached to the dine, they'll be away from the plane. And if this dinophile will come on the top, they will be above the plane. Okay, so their orientation will change as per the attack of your dinophile. So similarly here, when I'll get the product, I will have this like this, but this will be above. So if you'll observe this here, it is, I'll not call it as exactly cis, but of course the orientation, the type of configurations were same. So both were having E configuration. So similarly, this is something it is retained in the product also. Configuration was same. E is actually anti, okay, but both were having the similar configuration. So that similarity is retained in the product as well. यहाँ पे एक E है तो दूसरा Z है. That's why we have retained that kind of stereochemistry in the product as well. So this is called as Alder's scene rule. Because of the suprafacial pathway, there is always a syn addition to one of the faces of the dine, or an all mutual addition to the one of the face of the dinophile, and due to which we always end up with the syn products. That means the stereochemistry of the product, it's completely depends on the stereochemistry of the reactant. Okay, if we have understood this part now, the reactions which I have written on the screen, it will be convenient for you to understand the next part. ठीक है, so understand, अगर डाइनोफाइल के रिस्पेक्ट में अगर देख रहे हो, तो डाइनोफाइल के अगर सब्स्टिट्यूएंट सिस है तो प्रोडक्ट में भी वो सिस ही रहेंगे. Okay, if you can see there are trans, the product may be trans rahenge. Okay, with respect to dine, if both have the same configuration, remember, then the similar configuration will be found even in the product case. Also, if the dinophile is attacking from the bottom, that is away from the plane, then the substituents which are attached to the dine, they'll also be away from the plane. So these few points you remember, then it will be easy for you to predict the product of no next few reactions. Okay, so now we are now taking different examples. ठीक है, जैसे मैंने बताया तुम्हें डाइन अलग अलग टाइप के हैं, इन आउट टाइप के हैं. So here the dine which we have taken is having EE configuration with the same substituents on it, that is A. Substituents जो है डाइन के ऊपर वो A है. So look at this dine, everyone. Can you see this dyne over here? This is the dyne which is having substituent. This is A and this is also A. Right now you can see this is E configuration and this is also E configuration. Okay. So at A, at the termini, symmetrical dyne. So we have a symmetrical dyne in the case, but the dinophile is not symmetrical, it is unsymmetrical, because if you see dinophile के ऊपर दो substituent यहाँ पे attached है. This is my dinophile which is having two substituent, one is X and one is Y. How these X and Y are attached with respect to each other? Are they on the same side or they are on opposite side? We can see they are on opposite
Trans.
side, right? And therefore dinophile का भी configuration क्या लिखा है हमने? E लिखा है. Okay, again I'm repeating what we have taken. We have taken dyne, okay, which is having two substituent on it, and both these substituents are same. We have taken only substituent A. Therefore, we call this a symmetrical dyne having configuration E, and this is also E. Okay. Then there is a dinophile. Dinophile is having two substituents. One is X and one is Y. Of course, the remaining valencies are nothing but the hydrogen. तो ये जो X और Y है, how they are attached? They are attached in the E fashion. So my dyne is symmetrical and dinophile is unsymmetrical. So these are the two reactants that we have taken for the reaction. Okay. Now, in the case of the dyne, understand, ये जो अभी हम ऊपर से देख रहे हैं, this is my phase 1. Okay. And the bottom face will be phase 2. Similarly, if you look at this, if you look at this particular orientation, ये जो X है, this is, it's like इसके वापस अभी जो फिलहाल तुम देख रहे हो on the top of this is my phase 1. This is the phase 1. फ्रंट पे जो दिख रहा है वो phase 1 है और जो बैक साइड पे है वो है phase 2. ठीक है. How the orientation is there. Now, when the dinophile, this dinophile is going to approach, the X will be oriented inside. Matlab, when I'm going to approach the dinophile, the X will be towards this dyne. Okay. X will be towards this dyne. So when the attack will take place now, which is the front face, this is phase 1. So phase 1 of dinophile. Phase 1 of dinophile is attacking phase 2. Phase 2 कैसा है डाइन का, ऊपर है या नीचे है? बैक. ओके. फ्रंट अभी फिलहाल अभी जैसे तुम उसको देख रहे हो, ऊपर के जो भी फेसेस है दे आर phase 1. Okay. And the back faces are phase 2. I'm saying front side of dinophile. So phase 1 of the dinophile is approaching the phase 2 of dyne. So this particular part, if you remember, they're attacking the dyne from the back side. Do you remember what I told you before this? What I told you before this? जब ये डाइनोफाइल बैक साइड से अटैक करता है, how this R will be oriented? How this R will be oriented? They'll go away from the plane. Are you getting this? Are you getting this? जब डाइनोफाइल उसको बैक साइड से अटैक करेगा डाइन को, हाउ दिस आर विल बी ओरिएंटेड? दे विल बी अवे फ्रॉम द प्लेन. So that same point you remember here. Can you see instead of the R what we have here? A. So how this A will be located in the product? Can you see? They are below the plane. Have you understood why they are below the plane? Because your dinophile is attacking the dyne from back plane. And hence the A is moving away from the plane. ठीक है. अब look at your dinophile system. Dinophile system जो है उसमें X जो है, X is inside. X is attacking from that dyne from the back side. तो of course जब X back side से attack कर, ये जो dinophile जो है वो attack कर रहा है, so of course जो X है that will move away from the plane. So again X is away from the plane. और अगर x अवे फ्रॉम द प्लेन है, सो डू यू रिमेंबर इन द केस ऑफ दिस वी हैव सेड डायनोफाइल के केस में क्या है, जो स्टीरियोकेमिस्ट्री प्रोडक्ट रिएक्टेंट में है वही स्टीरियोकेमिस्ट्री प्रोडक्ट में होना चाहिए। तो अभी तुम रिएक्टेंट का स्टीरियोकेमिस्ट्री देखो, x एंड y एक दूसरे से कैसे है, they are cis or trans to each other, they are trans। तो अगर x is away from the plane, the y will be above the plane। Okay, if x is below the plane, the y will be above the plane। So this is the product which is obtained when it is obtained when the x is oriented inside, when x is oriented inside। ओके, अब उन्होंने क्या किया है, ये a x and y को they have given the priority for it is just given for the sake of example। So a is having higher priority, then x is having the next priority and y is having next priority। तो अब तुम अगर CIP rules use करोगे, so accordingly you can give the configuration to that। okay, so here अब क्या किया है, दिस इज सुप्रा सुप्रा, ये सुप्राफेशियल सुप्राफेशियल इंटरेक्शन है, बट दिस इज वन अप्रोच। नाउ लुक एट द सेकेंड अप्रोच। सेकेंड अप्रोच क्या है, एक्स इनसाइड ही है, एक्स इनसाइड ही है। ओके, बट कैसे है देखो, एक्स इज इनसाइड ओनली, बट हाउ इट इज लोकेटेड on the top here। So now why it is located like this, again you understand, we are now saying the phase 1 of the dinophile। phase 1 कहाँ पे है डायनोफाइल का, यहाँ पे हमने ये जो सॉरी डाइन ड्रॉ किया था, ये है A एंड दिस इज A, राइट। तो दिस इज phase 1 एंड बैक साइड पे क्या हुआ, phase 2। अब मुझे क्या दिखाना है, फेस 1 ऑफ द डाइन, मतलब ये फेस 1 डाइन कहाँ पे होना चाहिए, नीचे। तो अगर मैं उसको इन्वर्ट करूंगी तो मुझे सिमिलर स्ट्रक्चर ही मिलेगा, मुझे सिमिलर स्ट्रक्चर ही मिलेगा, बिकॉज मेरा जो भी हमने डायनोफाइल लिया है वो कैसा है, डायनोफाइल जो लिया है वो कैसा है, इट इज सिमेट्रिकल। बिकॉज ऑफ दिस फेस 1 और फेस 2 अगर तुम इंटरचेंज भी करोगे तो सेम ही दिखने वाला है। ठीक है, अब यहाँ पे तुम्हारे डायनोफाइल को देखो, डायनोफाइल का ये फेस 1 था, फेस 1 डायनोफाइल का कैसा था, अगेन आई एम ड्रॉइंग हियर, एक्स वाज इनसाइड, दिस इज वाई, दिस इज एच एंड दिस इज एच। अब मुझे फेस 2 ड्रॉ करना है। ओके, मुझे अभी फेस 2 ऊपर चाहिए, तो फेस 2 ऊपर चाहिए तो क्या करोगे, आई विल इन्वर्ट दिस वाया दिस एक्सिस, तो इसको रोटेट करोगे, रोटेट किया तो क्या हुआ, y यहाँ पे आ गया और x वहां पे चला गया। इसको, इस पर्टिकुलर मॉलिक्यूल को यहाँ पे थ्रू दिस एक्सिस 180 डिग्री इन्वर्ट किया। तो 180 डिग्री इन्वर्ट किया तो y इज आउटसाइड ओनली, x इज इनसाइड। सो x ओरिएंटेशन इनसाइड हैज टू वेज, आइदर तुम x को डाउनवर्ड्स लो या x को अपवर्ड लो। तो देयर आर टू वे इंटरेक्शंस पॉसिबल। अब ये रिएक्शन जब होगा, अगेन दिस इज अप्रोचिंग फ्रॉम द बॉटम, राइट। So these two A will be away from the plane, can you see they are away from the plane। okay, अब ये जो हाइड्रोजन है, can you see here this hydrogen when it is going to attack this dime, it is going to be away from the plane। अगर हाइड्रोजन is away from the plane, what about Y, this will be above the plane। okay, this will be above the plane। similarly यहां पे अगर तुम देखोगे x is inside, right, when it is inside, when it is attacking the dyne, it will move away from the plane। अब यहाँ पे देखोगे तो हमने इसको थोड़ा स्ट्रक्चर को उल्टा किया है, मतलब x ऊपर आ गया है, y नीचे है, यहाँ पे y ऊपर था, x नीचे है। तो उसको साथ सिमिलर वे में कंपैरिजन करने के लिए हमने क्या किया, वी हैव टर्न दिस मॉलिक्यूल वाया 180 डिग्री, बट कैसे टर्न किया, थ्रू दिस एक्सिस। ओके, जस्ट रिंग को फ्लिप किया, तो रिंग को फ्लिप किया तो व्हाट विल हैपन, जो A है विच इज बिलो द प्लेन, दे विल कम above the plane। can you see here, now the A are above the plane। what will happen to x and y, x will come down and y will come up, but y कैसे होगा, below the plane and x will come above the plane। वापस what I was explaining to you, Again I'm repeating. ठीक है, दिस इज माय डाइन सिस्टम, राइट? ये डाइन का फेस 1 है, और जो बॉटम में होगा वो क्या है? फेस 2 है। ठीक है, अभी ये जो हम देख रहे हैं डाइनोफाइल का, ये फेस 1 है। ठीक है, अब फेस 1 ऑफ दिस इज अटैकिंग फेस 2 ऑफ डाइनन, राइट? सो फेस 1 किसका है? डाइनोफाइल का। और फेस 2 किसका है? डाइन का। जब ये अटैक होगा, सिंस योर डाइनोफाइल इज अटैकिंग फ्रॉम द बॉटम, what will happen to A? Tell me. Away. Both are away. Okay. Now X is inside. X is inside, right? So how it will be located in the product? Above or below the plane? X डाइन को अप्रोच कर रहा है ना, तो वो डाइन की तरह ऊपर जाएगा, या इट विल गो अवे फ्रॉम द प्लेन? ये इंटरेक्शन स्ट्रॉम कब बनेगा? जब एक्स कहा जाएगा बिलो द प्लेन, बिकॉज वो ऊपर नहीं आ सकता ना। योर डाइनोफाइल इज अप्रोचिंग द डाइन, ऊपर डाइन है, तो एक्स क्या आ जाएगा? एक्स विल कम बिलो द प्लेन। अगर एक्स बिलो द प्लेन है, व्हाट विल हैपन टू वाई? इट विल बी अबाउट द प्लेन। ओके, दिस इज माई प्रोडक्ट फॉर दिस। ठीक है, अब मैं क्या कर रही हूं? इसको, इस पर्टिकुलर मॉलिक्यूल को 180 डिग्री से रोटेट कर रही हूं थ्रू दिस एक्सिस। एम आई गोइंग टू गेट द सेम थिंग? यस। अभी मुझे बताओ, नीचे
Yes,
कौन
ma'am.
सा फेस है? अभी फेस 1 आ गया ना, रोटेट किया ना मॉलिक्यूल को तुमने। और अभी
Yes, ma'am.
ऊपर कौन सा है? फेस 2।
Phase two.
ओके, अब इंटरेक्ट कौन करेगा? किसका फेस 1 इंटरेक्ट करेगा? डाइन का। ओके, अब डाइनोफाइल को देखो, डाइनोफाइल को भी 180 डिग्री रोटेट करना है थ्रू दिस एंगल। अब मुझे बताओ क्या ड्रॉ करूं? यहाँ हाइड्रोजन, यहाँ पे, यहाँ पे
Y.
y आएगा, यहाँ पे क्या आएगा?
X.
x, और यहाँ पे क्या आएगा?
H.
h आएगा। ठीक है, कैन आई से नाउ फेस 2 इज अप नाउ?
Yes.
यस, फेस 2 इज अप। तो अब फेस 2 किसका रिएक्ट कर रहा है? डाइनोफाइल का। अब ऐसे अप्रोच होगा। ठीक है, व्हाट विल हैपन टू दोज ए? यस, इट विल बी बिलो द प्लेन। डाइनोफाइल कहाँ से आ रहा है? बिलो द
Opposite
प्लेन
side.
ना, वैसे ही ए भी ओरिएंटेड बिलो द प्लेन ही होगा। तब जाके ये जो पर्टिकुलर कार्बन है, दैट विल बी इजीली अवेलेबल फॉर द बॉन्डिंग। ओके, अब देखो ये हाइड्रोजन कहाँ जाएगा? away from the
Okay.
viewer, right? If the H is going away from the viewer, what will happen to Y? Above. So this Y is above. Okay, what about this X? Below. So it will be below the plane. ठीक है, अब मुझे ये स्ट्रक्चर को और ये स्ट्रक्चर को कंपेयर करना है, बट इन दिस केस सी, y इज अप एंड x इज डाउन। यहाँ पे क्या है? x इज अप, y इज डाउन। तो पहले तो उसको ठीक करो। सो आई एम गोइंग टू रोटेट दिस मॉलिक्यूल थ्रू 180 डिग्री। तो जब 180 डिग्री करोगे, हाउ टू ड्रॉ दैट a? ऊपर। सो दिस विल बी a, y ऊपर आ जाएगा यहाँ पे, बट कैसे होगा? बिलो द प्लेन, अबाउ द प्लेन? बिलो द प्लेन। एंड व्हाट अबाउट x? अबाउ द प्लेन। दोनों ओरिएंटेशन अभी हमने पढ़े, वो दोनों ओरिएंटेशन कैसे थे? x was inside, right? x was inside। सिर्फ डिफरेंस क्या था? here the x is down, here the x is on the upper side। that was the difference। ये जो मैंने स्क्रीन पे दिखाया ये साइड पे, वो वही दिखाया है मैंने। आर यू गेटिंग? नाउ सी द सेकेंड ऑप्शन, x is oriented outside। Okay, again how the dinophiles are approaching? From the bottom. So where A will be located in the product? Away. Can you see this? Away? A is away from the plane, right? Now look at this, x is outside, x is outside. अब ये जो हाइड्रोजन है, ये हाइड्रोजन कहाँ पे जाएगा? Below. If that hydrogen is going below, x will come up.
Above.
Okay, so x is coming up. And now we can see y is inside, right? Y is inside, so that will go below the plane. ठीक है, ये हो गया हमारा सुप्रा सुप्रा थर्ड ऑपरेच. मतलब अब क्या हुआ, सी फेस 2 ऑफ डाइन था, फेस 1 ऑफ डाइनोफाइल, ये भी तो वही है, बट सिर्फ यहाँ पे क्या है, x इज इनसाइड, हियर x इज आउटसाइड. ओके, सिमिलरली इसको वापस हमने 180 से रोटेट किया, इसको भी 180 से रोटेट किया. अब मेरा x ऊपर की ऊपर आ गया. वैसे ही हमने इसको ड्रॉ किया जैसे हमने इसको किया था, देन अगेन 180 डिग्री से रोटेट किया एंड दिस. सो देयर आर टोटल 4 प्रोडक्ट्स आर ऑब्टेन. जैसे हमने बात की थी कि सिन सुप्राफेशियल सुप्राफेशियल में भी कितने प्रोडक्ट मिलते हैं हमें? 4. तो ये 4 कैसे मिलते हैं? दैट वी हैव डिस्कस्ड. BEE-dine with the same substituents A, so it is symmetrical dine and symmetrical dinophile. ठीक है, अब करेक्ट है वो. अब देखो, ये जो 2x है, हमने Z इनोलेट लिया है, Z डायनोफाइल लिया है. Z डायनोफाइल मतलब the x will be on same side, right? X will be on same side. But there are two approaches. Either these two x will be oriented inside or they will be oriented outside. Okay. अब यहाँ पे दोनों oriented inside है, तो यहाँ पे approach करेंगे A and A. Since dienophile is approaching from the bottom, we can say they'll be below the plane. X अंदर ही है, मतलब दोनों भी क्या आएंगे? Below the plane. Okay. अब यहाँ पे देखो, यहाँ पे क्या हुआ? सेम थिंग. ये सिमेट्रिकल है ना, तो इसको 180 से रोटेट किया, ये भी सिमेट्रिकल है, 180 से रोटेट किया. इज देयर एनी चेंज? कैन यू ऑब्जर्व एनी चेंज नाउ? दोनों सिमेट्रिकल है, इसलिए रोटेट करने के बाद भी दोनों सेम दिख रहे हैं. देखो, सुप्रा सुप्रा 1 एंड सुप्रा सुप्रा 2 देखो, कैन यू सी एनी चेंजेस इन दैट? नहीं, और इसलिए प्रोडक्ट सेम है. ओके, एंड सिंस हमने 180 से रोटेट किया, हमने प्रोडक्ट को भी 180 से रोटेट किया, एंड दैट्स व्हाई वी हैव रिटन दिस अनदर प्रोडक्ट. तो चारों भी अबव द प्लेन आ गए. ओके, अब दोनों आउटसाइड है. दोनों आउटसाइड मतलब दीज टू विल बी अवे फ्रॉम द प्लेन एंड दीज टू विल बी अबव द प्लेन. फेस 2 चेंज किया, सेम अप्रोच है, इसलिए प्रोडक्ट वही मिला, बट 180 से रोटेट किया तो ये मिलेगा. रिएक्टेंट को 180 से रोटेट करोगे तो प्रोडक्ट को भी 180 से रोटेट करके ही फाइनल प्रोडक्ट देखना. चलो इसका प्रोडक्ट लिखो. राइट, A will be away, B also away, Y is
Towards X away.
towards X is away. ओके, अब इसको 180 से रोटेट करेंगे. ठीक है, यहाँ पे A आ जाएगा, यहाँ पे B, राइट? और इसको रोटेट
Yes.
किया तो अभी इसका प्रोडक्ट कैसे आएगा?
A, B और X towards हो जाएगा इस बार,
बट
और Y
B
away.
अभी ऊपर रहेगा ना,
हाँ.
और A डाउन, राइट? X will be away,
Y towards.
Y towards, right?
इसको फिर
बट
180
इसको
में
180 से
convert
डिग्री
करके
करेंगे. हाँ, एंड देन A will come.
A, B, X towards हो जाएगा और Y away.
Absolutely right. Okay, like this. तो वही ये थर्ड स्लाइड पे आया है, देखो. E है, बट विद डिफरेंट सब्स्टिट्यूएंट्स A एंड B. ठीक है, डाइनोफाइल भी E है विद X एंड Y. ओके, अभी फिलहाल जो अप्रोच हम देख रहे हैं ना, दिस इज एक्स ओरिएंटेड इनसाइड ओनली, एक्स ओरिएंटेड इनसाइड ओनली। ये पूरा स्क्रीन स्लाइड पे जो दिख रहा है वो एक्स इनसाइड ही है। बट इस केस में जो हमने दो स्टडी किए थे उसमें एक्स टूवर्ड्स ए है, तो टूवर्ड्स ए ऐसे भी हो सकता है, टूवर्ड्स ए ऐसे भी हो सकता है। ओके, यहाँ पे वो टूवर्ड्स क्या है, बी।
बी।
ओके, तो कितने प्रोडक्ट हो गए, 4।
4।
ओके,
तो इसको तो पूरा ऐसा 8 हो जाएगा ना, अगर
ऑफ
वाई का
कोर्स,
ओरिएंटेशन
यस।
देखेंगे तो।
तो एक्स ओरिएंटेड आउटसाइड, ये देखो, टूवर्ड्स ए एंड टूवर्ड्स बी। बिकॉज यहाँ पे क्या है, डाइन के पास भी सब्स्टिट्यूएंट अलग है और डाइनोफाइल के पास
दोनों
भी है,
अनसिमेट्रिकल हो
दोनों
गए।
अनसिमेट्रिकल है। जब दोनों सिमेट्रिकल होते हैं या कोई एक अनसिमेट्रिकल होता है, इन दैट केस वी गेट ओनली वन, लाइक 4 प्रोडक्ट्स।
4 प्रोडक्ट्स,
बट चारों अनसिमेट्रिकल जब हो जाते हैं तो हमें
8
टोटल
प्रोडक्ट्स।
मिलते हैं 8 प्रोडक्ट्स। तो आई एम गोइंग फॉर द नेक्स्ट सिलेक्टिविटी नाउ। तो अभी हमने क्या देखा कि आउट ऑफ दो 16 स्टीरियोआइसोमर्स ओनली 4 कैन बी फॉर्म्ड। ओके, अनलेस एंड अनटिल दोनों अनसिमेट्रिकल है तो 8 केसेस हो जाते हैं, बट फॉरगेट अबाउट दैट केस नाउ। अगर हमारे पास प्रोकायरल अल्डिहाइड प्रोकायरल इनोलेट है और प्रोकायरल डाइन एंड डाइनोफाइल है, so of course we are going to end up with the 4 products out of those 16, we have now only 4। अब वो 4 में से भी what are these 4 products, I told you these are 2 endo and 2 exo products। एंडो में भी 2 प्लस माइनस है, राइट, एक्सो में प्लस माइनस है। नाउ एंडो एक्सो सिलेक्टिविटी जो है, इसमें ये जो टर्मिनोलॉजी है, दिस टर्मिनोलॉजी इज जनरली यूज्ड फॉर द साइक्लिक डाइन्स, जैसे साइक्लोपेंटाडाइन। ओके, सो डाइन सिस्टम जो होता है वो जनरली साइक्लिक होना चाहिए, तब जाके हम ये एंडो एंड एक्सो सिलेक्टिविटी को यूज करते हैं। Now, in suprafacial addition, we have said that out of those 4 approaches, only one approach is possible. That is supra and supra. Supra gives 4 products, 2 endo, 2 exo. But according to the elders endo rule, the endo product is predominating over the exo product. Okay. अब ये endo और exo में से endo क्यों prefer होता है? Let us understand that reason again. But to have this endo selectivity, that also you understand that dinophile जो होगा, that should at least contain one carbonyl group. If this particular condition is satisfied, then only this Alder's endo rule is valid. टू थिंग्स, एक तो तुम्हारा डाइन जो है वो साइक्लिक होना चाहिए, ठीक है, और तुम्हारा जो डाइनोफाइल है उसके ऊपर कार्बोनिल ग्रुप होना चाहिए। ओके, फॉर एग्जाम्पल हियर सी दिस, if you can see in this case the dine is cyclopentadiene hai, and if you look at the dinophile it is having this ester part here, so it is having the carbonyl group. So according to now supra approach हमने देखा है, you can see now this particular carbonyl group, can you see this particular carbonyl group, can I say it is towards the dine but upper side, this is towards the dine but bottom side. This is when this particular group is towards the dine, it is going to give me 2 endo products. Okay, so this is my endo 1 and this is my endo 2 product. When this is away from the dine, either it is up or it is down, it is giving me 2 exo product. Okay, so supra is giving me 2 exo and 2 endo products. Now what the Alder's endo rule says कि ये जो endo product form हो रहे हैं ये दो, these are the preferred product compared to the exo. Now why this happens, understand. Now these are the, you can see ये जो orbitals है ना, ये चार जो दिया है ना, these are your orbitals of the dine and these are your orbitals of the dinophile. So when this particular interaction is there between the dine and the dinophile, see this is your primary interaction which is expected. तुम्हारे ये जो dine के terminal orbitals है, they are going to interact with the orbitals of the dinophile. Apart from that, if you see here, दिस इज योर कार्बोनिल ग्रुप, ये जो तुम्हारा कार्बोनिल ग्रुप है, ये तुम्हारा C डबल बॉन्ड O है. This carbonyl group is also creating few interaction. ये जो है ना, ये वाला जो interaction तुम्हें दिख रहा है, this is your additional interaction. Now this additional interaction is a secondary interaction. What is the secondary interaction? It can be hydrogen bonding, it can be dipole dipole interaction, so it can be anything else but not a chemical bonding. ये जो यहाँ पे हो रहा है ये chemical bonding है, देखो ये primary interaction है. When I say primary interaction, that means it is exactly a chemical bond. It can be covalent or anything you say. But मैं जब secondary बोलती हूँ तो secondary is nothing but hydrogen bonding, the dipole dipole interaction, van der Waals forces. So that kind of forces we can expect. So you can see when there is an endo approach. Endo approach मैंने क्या बताया था? Endo क्या होता है? How the substituent carbonyl group is located towards the diene or away from the diene?
Towards the dyne for endo.
Towards the dyne. So when it is towards the dyne, it is creating this kind of secondary interaction. Secondary interaction stabilizes the system. ओके क्योंकि ये सेकेंडरी इंटरेक्शन क्या है, हाइड्रोजन बॉन्डिंग है या वैंडरवाल फोर्सेस है या डाइपोल डाइपोल इंटरेक्शन है, तो सिस्टम को वो स्टेबिलाइज करते हैं. ओके एंड दैट्स व्हाई द एंडो प्रोडक्ट फॉर्मेशन बिकम्स इजी. वही जब हम एक्सो अप्रोच की बात कर रहे हैं, सी दिस इज माय डाइन, ओके एंड दिस इज माय डाइनोफाइल. मेरा प्राइमरी इंटरेक्शन एज इट इज है, प्राइमरी इंटरेक्शन तो होगा, होने ही वाला है, राइट? बट लुक एट योर कार्बोनिल ग्रुप नाउ. माय कार्बोनिल ग्रुप इज हियर. Is it having that secondary interaction with the dyne now?
No, less
No.
stability.
Yes, it is less stable. तो वो secondary interaction जो है वो कहीं ना कहीं endo approach में ज्यादा मिलता है. And that's why endo product is preferred over the exo. The next approach now, uh, regioselectivity, which is not connected with this topic at all. I'm just taking because stereoselectivity जब discuss करते हो तो of course regioselective is, it is also important. That means how your dinophile and the dyne they are interacting and which are the region where it will be attacking. For example, these rules are fixed. Dyne and dinophile when both are unsymmetrical. Okay, there is a possibility of regioisomer. जैसे अब यहाँ पे देखो, this is one substituted dyne and this is dinophile. So when they are going to interact, okay, when they are going to interact, either I can have this kind of interaction or I can take this X down. So either I will get formation of ortho or I will get formation of meta isomer. So when I have this kind of approach, generally it is observed the ortho product is a major product compared to meta. Secondly, similarly, जब मेरे पास two substituted dyne होगा, similarly x either up, so it will become a meta type of compound, और x अगर down हुआ तो वो para type of compound होगा. तो of course वहां पे para is a major product compared to meta. So it is depending on how your dyne and dinophile उनके faces कैसे approach करे, वापस वही है, x either will be upper side or it will be down side. तो depending on मुझे दो product मिलेंगे, ortho para या सॉरी orthometa या फिर parameta. Meta is generally not preferred. Ortho and the para is the major product which are formed in the reaction. This has actually no connection with whatever we were talking till now. Okay, but I have discussed this aspect also because this is also one of the type of stereoselectivity. Okay, now let us come back to that point. हमने Woodward Hoffman suprafacial से decide किया out of 16 4 will be obtained and out of 4 only 2 will be obtained, which was decided on the basis of Alder's endo rule. Okay, now we are going for the actual approach. Okay, these are some examples I have given. You can go through it ki, where the ortho is formed as a major product and the para is formed as a major product. तो ये कुछ examples यहाँ पे दिए हैं. Okay, this is the last part, that is asymmetric Diels-Alder reaction, जहां पे हमें देखना है कि वो जो दो प्रोडक्ट तुम्हें मिल रहे हैं वो दो में से मुझे एक ही प्रोडक्ट कैसे मिलेगा. That means how to induce the asymmetry, that we're going to talk about in this part, that is called as asymmetric Diels-Alder reaction. Okay, now here there are three different ways of inducing the asymmetry in the case of Diels-Alder. Either you attach the chiral auxiliary to the dinophile, or you attach the chiral auxiliary to the dyne, or use chiral Lewis acid catalyst. Okay, what is chiral? Or get some environment chiral, then only you will be able to get the purity. Okay, so here what we're going to do, we are going to either make our substrate chiral. तो हमारे पास substrate कौन है, डाइन है और डाइनोफाइल है. तो आइदर डाइनोफाइल को कायरल बनाओ या डाइन को कायरल बनाओ. तो दोनों को कायरल बनाना है तो हमने क्या किया, उसको क्या अटैच किया, ऑक्सिलरी, या फिर रिएक्शन में लेके आओ, दैट इज लेविस एसिड कैटलिस्ट. अब यहाँ पे फर्स्ट अप्रोच हम देखने वाले हैं, अटैचिंग कायरल ऑक्सिलरी टू द डाइनोफाइल. दिस इज वन ऑफ द बेस्ट अप्रोच. अगर तुम डाइन और डाइनोफाइल को भी कंपेयर करोगे ना, तो डाइनोफाइल को कायरल ऑक्सिलरी अटैच करना इज अ बेटर ऑप्शन, जनरली इट इज फाउंड. And there are a lot of chiral auxiliaries which are available in the market now. Commercially there are a lot of compounds, jaise you can see this is a menthol, and they have made a derivative of menthol which is 8 phenyl menthol, which is a Corey's catalyst it is called as. Then this is camphor based catalyst which are prepared by the opalzers. So it is ether type of alcohol compound which is camphor based ethers hai. फिर oxazolidine which is called as Evans catalyst. Okay, and finally this is a mesetyl trifluoroethanol, ये वापस कोरेज कैटलिस्ट है. तो ये जो तीन साइंटिस्ट है, कोरे, इवांस, this Apple's, this is like they have worked on these kind of asymmetric discrimination processes a lot, and they have derived or they have prepared these kind of auxiliaries. These auxiliaries are readily available in the market, and you can think about attaching these auxiliaries to the molecule. Okay, तो अब इसको attach कैसे करते हैं और reaction कैसे होगा, that you understand. Okay, first of all look at this dinophile. This is double bond attached to COH. Is there any chirality in this dinophile is present? नहीं, ठीक है, इसमें कोई भी chirality नहीं है. But is it prochiral? Yes, it is prochiral. ठीक है, अब हम क्या करने वाले हैं, यहाँ पे लिया गया, this is fumaric acid, and this auxiliary which is used is menthol. So we are attaching now this menthol to the fumaric acid. Of course, this is alcohol and this is acid. So what product is expected to form? Ester. ठीक है,
Ester.
तो हमने अब ये देखो, ये तुम्हारा फ्यूमेरिक एसिड का डबल बॉन्ड है, एंड हमने अब ये दोनों जो एसिड पार्ट है उनको बनाया एस्टर. सो वी हैव इंट्रोड्यूस्ड द एनेंशियो प्योरिटी इन दिस कंपाउंड. अब तुम्हारा डाइनोफाइल कैसे हो गया? कैन आई से इट इज एनेंशियोमेरिकली प्योर नाउ? ओके, सो इट इज प्योर नाउ. Now this is allowed to react with this cyclopentadiene, okay, in presence of this catalyst. Lewis acid catalyst है, नॉर्मल लेविस एसिड कैटलिस्ट यूज किया है, वो एल्यूमिनियम क्लोराइड सॉल्ट टाइप है. सो नाउ व्हेन दे हैव यूज्ड इट, दे आर गेटिंग दिस प्रोडक्ट, उसको एंडो प्रोडक्ट मिलने वाला है. ठीक है, एंडो प्रोडक्ट जो मिलेगा वो कैसे मिलेगा, कितने एंडो प्रोडक्ट मिलेंगे? दो
side.
प्रोडक्ट मिलेंगे, प्लस और माइनस, राइट. बट कैन यू ऑब्जर्व दिस, 99% डाइस्टीरियो सिलेक्टिविटी. अब तुम्हारे दो प्रोडक्ट फॉर्म होने थे एंडो, अब वो एंडो में से भी अगर तुम देखोगे तो प्लस कितना है, 99.5, और माइनस कितना है, 0.5. So this is called as the chiral auxiliary attached to the dinophile is inducing the asymmetric Diels-Alder reaction. मैंने और एक एग्जांपल लिया है, ठीक है. यहाँ पे अगर तुम देखोगे, सो दिस इज जो 8 फिनाइल मेंथॉल था ना, वो वाला मैंने स्ट्रक्चर यहाँ पे लिया है. दिस इज द कायरल ऑक्सिलरी, दिस इज द डाइनोफाइल अगेन. यू कैन सी ये जो डाइनोफाइल है उसको अटैच किया. ठीक है, यहाँ पे सिंपली एक क्लोरीन है और यहाँ पे OH है, सो HCl will be lost and we will get this particular menthol part will be attached to this dinophile. Now this dinophile is further attached, or sorry, further allowed to react with this dine, and we end up with the product. You can see one is 94.5 and one is 5.5. दोनों फॉर्म हुए हैं but unequal amount, so I can call this as asymmetric Diels-Alder reaction. I'm taking the next example where I'm going to attach the chiral auxiliary to the dine. Here there are very few examples available in the literature because डाइन को कायरल ऑक्सिलरी अटैच करना इट्स अ वेरी डिफिकल्ट टास्क बिकॉज तुम्हारा डाइन इज ऑलरेडी अ क्राउडेड सिस्टम एंड टू दैट attaching the chiral auxiliary, then the system, or you can say substrate, becomes more complicated to give the reaction. Still there are few examples available, jaise Ender and Trost. These are the two scientists. They have discovered these two chiral auxiliaries. First is 2-methoxymethyl pyrrolidine and next is O-methyl mandelic acid. So these you can say this particular compounds we can attach to the dine system. अब देखो यहाँ पे ये तुम्हें डाइन दिख रहा है, this particular dine. Okay, this particular dine is attached to this auxiliary. This is 2-methoxy methyl pyrrolidine system. So we have made this dine right now chiral by attaching the auxiliary. This is my simple dinophile, which is prochiral in nature. Of course, now how the dinophile is going to approach, whether it is going to approach from the top or the bottom, it is being completely controlled by this auxiliary. Right now, you can see this auxiliary is on the top. Therefore, it is expected the dinophile is going to approach from the bottom. And hence I'm going to end up with the product. यहाँ पे देखो स्टीरियोकेमिस्ट्री, ये जो R ग्रुप सॉरी एरोमेटिक ग्रुप है एंड नाइट्रो ग्रुप है, इसका एक स्टीरियोकेमिस्ट्री यहाँ पे बन गया है एंड दैट इज completely decided by this auxiliary. Once I get my selectivity, I will remove this auxiliary, so I will get my expected product. Here I'm getting the product with the 98% of distereo selectivity, and therefore we are going to call this as asymmetric Diels-Alder reaction. समझ? ठीक है, दिस इज अनदर एग्जाम्पल. वो जो मैंने मेंडेलिक एस्टर्स बताया था, यू कैन सी दिस इज मेंडेलिक एस्टर यहाँ पे अटैच किया है डाइन को. दिस इज डाइनोफाइल. वी आर गेटिंग द सिलेक्टिविटी एंड वंस वी गेट द सिलेक्टिविटी वी कैन रिमूव दिस ऑक्सिलरी. Okay, here they are getting up to 94% of enantiomeric excess. So in short, we can attach chiral auxiliary to the dine, or we can attach chiral auxiliary to the dinophile to get the asymmetric Diels-Alder reaction. Out of those 16 stereoisomers, we are ending up with only one stereoisomer. That's why we are calling this as asymmetric Diels-Alder reaction. Okay. Now here till this part what we have studied कि हमने auxiliary attach किया था either डाइन को या फिर डाइनोफाइल को. अब हम क्या कर रहे हैं, अभी हम अटैच कर रहे हैं ये जो auxiliary to both. That means your dine as well as your dinophile is going to be chiral. Okay, look at this. This is my dine having this chiral auxiliary part. This is my dinophile having this chiral auxiliary part. Right now you can see this is having S configuration and this is also having S configuration. This दोनों का configuration similar होना ये जरूरी नहीं है. ठीक है, हमने इसका S और उसका S configuration लिया है. And when we are getting the product, now see, मुझे कैसे product मिला? 130:1 ratio. डायस्टीरियो selectivity कैसा है? 130:1. ठीक है, अब सिमिलरली मैंने क्या किया, इसका R isomer लिया. The chiral auxiliary which is attached to the dine, I have taken now R isomer of that and I kept this S isomer as it is for the dinophile. When I'm getting the product now, I'm getting 35:1. So which is a better combination? SS combination better है या RS combination better है? This is better. So when I'm taking two configurations of the dine and dinophile and I'm getting a better stereo selectivity, we consider this is a good combination of the two chiral auxiliaries. So when this kind of combination matches and when you get a better stereo selectivity, we call that as matched double distereo selective reaction. ओके, एंड सेकेंड एग्जाम्पल जहां पे दोनों का कंपैटिबिलिटी प्रॉपर नहीं है, इसकी वजह से हमें स्टीरियो सिलेक्शन नहीं मिला, सो वी कॉल दैट एज मिसमैच्ड डबल डायस्टीरियो सिलेक्टिव रिएक्शन. नाउ आई एम गोइंग फॉर द लास्ट अप्रोच ऑफ Diels-Alder रिएक्शन. अगर मुझे सबस्ट्रेट को कायरल नहीं बनाना है, जैसे हमने असिमेट्रिक सिंथेसिस के भी टाइप्स पढ़े थे, आइदर आई कैन मेक my substrate originally chiral, or I can attach chiral auxiliary to that. I can use chiral reagent, or I can use chiral catalyst, right? These are the four types of the asymmetric synthesis reaction we have studied. Now, this is the approach where we are going to use the chiral Lewis acid catalyst. Now, what is the role of this catalyst that you first of all understand? We have discussed there are diene and dienophile. Let us first talk about diene. Just 1 minute. Okay. I'll first talk about diene and then we'll talk about dienophile. Now, in case of diene, let us say this is homo of diene and this is LUMO of diene. Similarly, this is homo and this is LUMO. Okay. Now, generally, what we say, कोई भी approach चलेगा. Homo of diene interacting with LUMO of dienophile, or LUMO of diene interacting with homo of dienophile. Any interaction will do. Okay. जरूरी नहीं कि homo of diene ही हमेशा रिएक्ट करेगा और LUMO of diene ही हमेशा रिएक्ट करेगा. Any interaction will do. It's possible in case of Diels-Alder reaction. But what we say, to get a better reaction, generally हम expect करते हैं कि dienophile जो है ना, वो तुम्हारा होना चाहिए इलेक्ट्रॉन डेफिशिएंट, एंड डाइन जो होता है वो होना चाहिए इलेक्ट्रॉन रिच. तो ये केस में ये जो अप्रोच है ना, होमो ऑफ डाइन एंड लुमो ऑफ डाइनोफाइल, ये वाला अप्रोच बहुत इंपॉर्टेंट है. दिस इज अ प्रिफर्ड इंटरेक्शन जहां पे अच्छा इंटरेक्शन होता है एंड यू गेट अ स्टेबल प्रोडक्ट. Now, what happens when you are using the Lewis acid catalyst? Generally, जो Lewis acid catalyst होते हैं ना, वो तुम्हारे डाइन के साथ इंटरेक्ट करते हैं, बिकॉज ये कैटलिस्ट में मोस्टली जो कंपाउंड्स होते हैं, these are like salts होते हैं, they can be easily coordinated with these dinophiles. So when they coordinate with this dinophile, what happens to the energy level of dinophile? ये जो LUMO है, they interact with generally the non-bonding electrons of the dinophile, and because of this non-bonding you can say interaction with the dinophile, इसका जो LUMO का energy level है ना, वो decrease हो जाता है. Now the new energy level will be like this. So this will decrease the energy gap between this dino and dinophile. Okay, and that's why you get a better reaction. Of course, catalyst का तुम्हें हमेशा पढ़ा ही है. The catalyst always decreases the energy of activation. So somewhere here, the line that you need to remember, your Lewis acid catalyst is going to interact with the dinophile because they are electron deficient, and when they coordinate with this dinophile, the LUMO of dinophile decreases. Therefore, energy gap between the dyna and the dinophile, that is generally, you can say, it is decreased. And therefore, we when we are using this Lewis acid catalyst, they allow the reaction to be carried out at the lower reaction temperature and gives high endostereo selectivity because of the chelating effect. Because of course ये जो जितने भी Lewis acid catalyst है, इसमें जो metals है, they can form a coordinate bond, so it forms the chelation, it gives a chelation effect and giving more organized transition states. Okay, the first example this we have taken is the, I guess, Diels catalyst मैंने आगे लिखा है, right? हाँ, दिस इज द फर्स्ट एग्जाम्पल. कोरेज कैटलिस्ट हमने यहाँ पे लिया है. अगर तुम यहाँ पे ऑब्जर्व करोगे, लुक एट योर साइक्लोपेंटाडाइन विच इज अकाइरल, look at your dinophile which is achiral, but the catalyst which is used here, look at this catalyst, which is, this is indenyl oxaboroazolidine. Okay, oxaborolidine. So this particular catalyst is having this chiral center. तो अब जो भी इन्फ्लुएंस होगा, यू कैन सी इन दिस रिएक्शन वी हैव यूज्ड 5 mole% ऑफ द कैटलिस्ट. मतलब अगर हमने 1%, 1 मोल अगर दिस 1 मोल अगर तुमने स्टार्टिंग मटेरियल यूज किया है, तो उसका 5% हमने कैटलिस्ट यूज किया है. Okay, this is a solvent and generally these reactions are carried out at the low temperature. So here Of course, I'm going to get the endo and exo product. Here I'm getting the 96% of the distereo selection. And once I remove the, of course, this is a catalyst, so of course that won't be a part of your reactant. So you are getting this 99% of enantio selectivity in the reaction. ओके, एंडो प्रोडक्ट फॉर्म हो रहा है, बट एंडो और सॉरी एंडो एक्सो में जो सिलेक्टिविटी है दैट यू आर गेटिंग बिकॉज ऑफ द कैटलिस्ट. सिमिलरली ये जो टेडॉल्स कैटलिस्ट है, दिस इज टेडॉल्स. टेडॉल्स इज अ टिटेनियम का कॉम्प्लेक्स विद दिस tartaric acid. Okay, that is called as tedols. So it is the catalyst which is formed from the L plus or D minus tartaric acid with the titanium tetrachloride. अगर तुम देखोगे तो जो हमने शार्पलेस इपॉक्सीडेशन पढ़ा वहां पे भी हमने DT पढ़ा था विद टाइटेनियम कॉम्प्लेक्स. तो यही टेडॉल्स कैटलिस्ट है. This is used for this reaction. So for example, if you see, this is cyclopentadiene and this is dienophile. If it is reacting, I'm getting 94% of one isomer and 6% of the another isomer. This selectivity I'm getting because of the catalyst. So here the influencing factor is the catalyst in the reaction. Of course, catalyst has its role. It is going to interact with either diene or dienophile, and then generally it is found that it is interacting with your dienophiles, and then it will decide where the dienophile will attack the diene, whether it will interact, it is going to attack from the bottom side or the front side, and then accordingly the selectivity will be observed.